So when we talk about waves, the first thing I want you guys to remember is that there are two types of waves, transverse and longitudinal waves. And in transverse waves, as you can see up here, the direction of vibrations is perpendicular to the direction of energy transfer. Whereas in longitudinal waves, the direction of vibrations is parallel to that of the energy transfer. And if you're asked for examples of transverse waves, just remember that these are your EM waves, or the electromagnetic spectrum waves. So that's your radio waves, microwaves, infrared, ultraviolet, and so on. Whereas for longitudinal waves, we're talking about waves like sound waves. And if you look at this animation, you can see that the vibrations happen up and down, but the direction of energy transfer is along to the right, and that makes a right angle, hence perpendicular. Whereas with these longitudinal waves, the direction of energy transfer is side to side, and also the direction of vibrations is side to side, hence parallel. And with transverse waves, I want you to remember that the top of the peak is called a peak, and the very lowest point is called a trough. Now the distance between the undisturbed position, or the middle line, and the peak or the trough, that's called the amplitude. And the wavelength for transverse waves is always the distance between a peak and another peak, or a trough and another trough, or any position on one wave and that same exact position on the next wave. If we take a screenshot of a longitudinal wave, there are sections called compressions, and that's when the waves are compressed, and there are bits that are rarefactions, and that's where they're further apart. There's no peaks or troughs with longitudinal waves, but there are still wavelengths. So in order to calculate a wavelength, we look at a certain point on one wave, that might be on a compression, and that same exact point on the next compression. Of course, we could use a point on the rarefaction and the next point on that next rarefaction as well. I also want you all to remember that when a wave moves through a medium, energy is transferred, but the particles of matter in that medium don't actually move themselves. And you would see that if you put something in some water and you generated some ripples, yes, that object would move up and down, but its position would not actually change. It would not travel further or closer to you, even though the ripples will be moving. It's the same as when a speaker makes a noise. Those particles that vibrate next to the speaker don't actually travel to your ears in order for you to hear that sound. Instead, they'd vibrate the particles that are next to them and keep vibrating the particles that are getting closer and closer to your ear until it reaches your ears. I want you guys to remember that amplitude and wavelength are usually measured in meters, whereas the frequency, which is the number of waves that pass a particular point in a second, is measured in hertz. And remember that time period is the time required for a wave, a whole wave, to pass a particular point in seconds.